Hey everyone, our plan today is to finish up rational functions, and we're going to do that by having a small discussion on trying to write some rational functions. We're basically going to take everything we've learned and try to do it backwards. It actually often is quite a bit easier. As you're going to discover, it's just a matter of creating a numerator and denominator. So what if we want to write a rational function that's got a vertical asymptote at 3, horizontal asymptote at 0, and a whole at -2? Well, all it's going to take is a numerator and a denominator. Of course, it makes sense usually to start with the denominator. The denominator really contains most of your problems. So if there's going to be a vertical asymptote at 3, I guarantee your denominator is going to have an x minus 3. And if there's going to be a whole at -2, then we know that your denominator is going to have a problem for using x plus 2. Now you should be saying, yeah, but x plus 2's got to be in the numerator also, right? Right. So now we have a whole, we've got a vertical asymptote. How's that horizontal asymptote going? Yeah, it should be going pretty good because you know that the numerator has a degree of 1 and you know the denominator has a degree of 2. And so basically by default, we have created the horizontal asymptote. Students will sometimes ask, do I need to FOIL it out? I would say that if it was a multiple choice test, that you should be aware, obviously, that the denominator could be in more of a standard form, but I'm not going to get real picky and necessarily require that. Obviously, both these answers are the same. Next rational function. This time we've got vertical asymptotes at plus or minus 1 and a horizontal asymptote at 6. Now, if we were in the classroom, I would pause longer here and say, why don't you try this? So, well, you're still in a classroom, you're learning, so why don't you try it? What kind of denominator would you write? What kind of numerator would you write? Don't worry, I'm not going anywhere. I'll wait for you. If we were in the classroom, I would most likely see some denominators that looked similar to the last problem. In other words, some factors. And there's absolutely nothing wrong with that. Some students would have felt a little bit more like quickly or immediately writing as x squared minus 1. Obviously, that is also the same. So how's your horizontal asymptote? Now, you got to be careful. Okay, you got to be careful. But, if you put a 6x squared up here, that doesn't change the denominator. What it does do, though, is allow you to have equal degrees. And so I think we can use 6 over 1 to say that our horizontal asymptote is going to be at 6. Okay, so 6x squared over x squared minus 1. But it's not the only correct answer. What if I don't like 6x squared? What if I like just the number 1? What if I want my numerator? What if I force you to make the numerator equal to 1? Now you should say, yeah, but now the asymptote's at 0. And I would say, right, it starts at 0. Could you make it shift to 6? Of course you could. All you got to do is put a plus 6. Now here's the cool thing. If you take this version, this shifted version, and you make a common denominator, see if I can squeeze that in there. You see what's going to happen? Whoop. See what's going to happen? We're going to end up with, the same thing. We're going to end up with a 6x squared. Now we get a little extra stuff. We get a minus 6. But interesting, shifting or just having a 6x squared, so shifting by 6 or just having a 6x squared, in essence, they're the same thing. Okay, now what we want to understand is that this equation right here is not necessarily equal to this equation here, but they still have the same asymptotes. Okay, they're going to look a little bit different because the one equation has that extra -6, which is just going to change the shape of the graph just a little bit. All right, do you get the idea? There's more than one right answer. You were wondering, would we have to do one with a slant, right? Well, if you have to do one with a slant, I'm not going to make you do long division backwards, although that might be kind of interesting. What I'm really making you do is just think a little bit about what has to be true about the numerator and denominator. The denominator's got to be x based on this problem. Your numerator, well, your numerator, now it's not going to have just 3x minus 2. That's right, we have to have a 3x squared minus a 2x. But there's one more thing. It's very interesting. It's actually the remainder. You see, without that plus c right there, I actually would not have a remainder, and therefore I wouldn't have that value that's pushing me away from the slant. In other words, if I had written it just as 3x squared minus 2x, what I actually did, knowingly or unknowingly, is I put a hole in the graph. I put a hole in the graph, and my graph is now going to just resemble 3x minus 2. In other words, there's no remainder, so there's no slant. Now let's be clear, this answer is not right, but this answer is right when I put the plus c at the end, which again gives me a remainder. That's the only kind of problem I'm going to make you do with a slant, one that has a simple denominator. Good problem to try. I don't know, is there any catch to it? Is there anything that you have to be careful about? We have a vertical asymptote at -2. We've got a hole at 0. I hope you're not just waiting for me. Why don't you guys see if you can write this equation? This is a good example of a problem where I hope you're not second guessing yourself too much. You definitely need an x plus 2. You definitely need an x. And just kind of double checking, nothing's going to change by putting those x's in there. In other words, it doesn't change the vertical asymptote, and the vertical asymptote doesn't change the hole. So we're good. We're going to end up with what we asked for. So we'll do another hole, but this time the graph is going to resemble 5x. Okay, now you have to realize that this gets into that sort of that specialty case. It's simply a specialty case where, well, where I want to make sure that after we do the division, okay, now go ahead and I'll put the parentheses around just the 5x. You see, these guys right here, they're going to give me a hole in the graph. Okay, but after I divide them, or after I cancel them, all I'm left with is that 5x. Okay, what that means is really that the graph is going to look like 5x. What's 5x? Remember, 5x is just a line. Okay, it's just a line. It has a slope of 5. Okay, but technically, it's a line that has a hole in it. It has a hole in it at 0. Okay, and the reason it has a hole there is because, well, because of these x's in the beginning. Sometimes kids will say, why do I bother putting those x's there in the first place? Well, you put them there because you want to have a hole in the graph. If you didn't put them there, you would end up with just a line. So we have a line that looks like 5x, but again, it's not. It's 5x with a hole in it, okay, which is technically a different kind of graph. It might be nice to write this as 5x squared over x, just because we can. All right, writing irrational equations. I want you to practice that concept a little bit. I want you to realize that some answers can vary, okay, but the essence of your numerator and denominator is going to be the same. And we'll see you back here next time.